Second real life example of prisoner's dilemma game is a joint project. Here the players are two students. Actions are work hard or shirking for both the players. Preferences are player 1 prefers that he shirks and the other player works hard over both of them working hard over both of them shirking, and the least preferred will be he works hard and the other person shirks. The preferences of the player 2 will be the player 1 will work hard and the player 2 will shirk over both of them working hard over both of them shirking, and the least preferred by the player 2 will be he works hard and the other player shirks. The game table will be like this. Both of them will shirk, both of them will get a payoff of 1. When player 1 shirks and player 2 works hard, player 1 will get a payoff of 3 and player 2 will get a payoff of 0. When player 1 works hard and player 2 shirks, then the player 1 will get a payoff of 0 and player 2 will get a payoff of 3. When both of them work hard, both of them will get a payoff of 2. Third real life example of the prisoner's dilemma game is a arms race. Here the players are two countries. The actions available to countries are building the nuclear bombs N or refraining the building of bombs, that is R. The preferences of the player 1 are that country builds nuclear bombs and the other country do not build, that is refrain, over both the countries refraining over both of them building the nuclear bombs over the country 1 refraining and the country 2 having the bombs. The preferences of the player 2 will be the country 1 refrains and the country 2 builds the nuclear bombs over both the countries refraining over both the countries having the nuclear bombs over country 1 having nuclear bombs and country 2 refraining the building of nuclear bombs. So the game table will be like this. N and R are the actions of the country 1 and N and R the actions of the country 2. The payoffs will be for NN it is 1 1, for NR it is 3 0, for RN it is 0 3, for RR it is 2 2. So where your action C of your prisoner's dilemma game here will be equivalent to the N and NC will be equivalent to the R. Next type of game is called BOS game or battle of sexes, where you have two players, husband and wife. Actions will be going to boxing match or going to opera house. The preferences of the player 1 will be both of them going to boxing match over both of them going to opera house, with the least preferred action will be each of them going to different matches. One going to boxing match and other going to opera house. Similarly, the preferences of the player 2 will be going both of them to opera house over going both of them to boxing match, and the least preferred will be each of them going to a different matches. Game table of BOS will be action for both the players will be B and O, B and O. When both of them go to boxing match, player 1 will have a payoff of 2 and player 2 will have a payoff of 1. When player 1 goes to boxing match and player 2 goes to opera house, both of them will get a payoff of 0. And when player 1 goes to boxing opera house and player 2 goes to boxing match, again they get a payoff of 0. When player 1 goes to opera house and player 2 goes to opera house, player 1 will get a payoff of 1 and player 2 will get a payoff of 2. Here husband prefers both going to boxing match, wife prefers both going to opera house. Both least prefer each going to different places. Real life examples of BOS game. First one is the political parties spending money. Here the players are two politicians. Player 1 is from Delhi and player 2 is from Bihar. The actions available to the players will be spending money either in Delhi or spending money in Bihar. The preferences of the player 1 will be, he belongs to Delhi, so he prefers that both of the politicians spend money in Delhi because he is from localite from Delhi, so he will be having more advantage if other politician also spends money in the Delhi. Over, he as well as other player both spend money in the Bihar. And the least preferred will be when both the players will select different places for spending money. The preferences of player 2 will be, because he is from Bihar, he prefers both of them spend money in Bihar over both of them spending money in Delhi, and the least preferred will be one spending money in Bihar and other spending money in Delhi. Second real life example of VOS game will be merging of old and new companies. Here the players are two companies, one is the old company and two is the new company. The actions available to companies are technologies A and B. Adopting the technology A and B. Preferences of the player 1 will be, because one is a old company, he prefers that the other company will adopt his technology over both of them adopting technology B, and the least preferred will be one using the technology A and the other using the technology B, or vice versa. Similarly, the preferences of the player 2 will be both the companies using the technology B, because it is the B's technology which is used by both the companies, over both the companies using the technology A, and the least preferred will be one using the technology A and the other using the technology B. Next type of game is a matching pennies game. Here the players are P1 and P2 and the actions available to the players are head or tail. The preferences of the player 1 will be, he prefers matching, so he prefers that both the players will get a head or both the players will get a tail, over one getting head and the other getting tail, or he gets tail and the other gets head. The preferences of the player 2 will be, player 2 prefers mismatching, where the actions which are preferred by the player 2 will be mismatching, that is HT or TH are having highest preference over HH and TT. So the game table of matching pennies goes like this. When both of them get head, it is profit for player 1, or when both of them get tail, it is profit, so the payoff is 1. When one is head, other is tail, and another is tail and he is head, so the payoff is -1 for the player 1. Similarly, for player 2, when both are getting head, it is -1, or both of them getting tail, the payoff is -1. And when one gets T and other gets head, it will be, a payoff will be 1. Real life examples of matching pennies game. The first example will be company's product appearance. So here the players are two companies. First one is a new company and the second is a reputed company. The actions available to the players are appearances of the companies, that is A and B. So preferences of the player 1 is, because the player 1 is a new company, so this new company prefers matching so that it can attract the customers. So the preferences will be AA and BB are same over AB or BA. The preferences too for the player 2 will be, since it's a old company or a reputed company, it prefers mismatching, so where the preferences will be BA or AB over AA or BB. Second real life example of matching pennies game is the cricket match. Here the players are, one is a batsman and the second is the bowler. The actions available to both the players will be either fast or slow. The preferences of the player 1, the batsman prefers matching, that is, the bowler throws the ball fast and he also catches it fast, or the bowler throws the ball slowly and he also bats slowly over the opposite actions, that is, one is slow and the other is fast. And the preferences of the player 2 will be bowler prefers mismatching because he wants to make the batsman out. So the preferences, high preferences for the bowler will be fast slow over and slow fast over fast fast and slow slow. Now we'll study what is the solution concept of game theory. It is called Nash Equilibrium. So Nash Equilibrium is a stable state of system involving the interaction of different participants in which no participant can gain by unilateral change of strategy if the strategies of the others remain unchanged. And this Nash Equilibrium is based on rational choice theory and the beliefs of the people regarding other players' actions are correct. The idea of steady state is that if the players are taking their action, then for none of them has a tendency to deviate away from that action. That is the equilibrium. So here it is a state of rest in this Nash equilibrium also. Given what I started with some expectations, if my expectations are satisfied, then I did not want to change my action next also. Expectations are formed from the experience and expectations are coordinated. Equilibrium is a steady state, stable outcome. A game may have 0, 1 or many Nash equilibrium. Nash equilibrium is a fundamental concept in the theory of games and most widely used method of predicting the outcome of a strategic interaction in the social sciences. A game consists of the following three elements: a set of players, set of actions available to each player, and a payoff function for each player. The payoff functions represent the player's preferences over the action profiles, where an action profile is simply a list of actions, one for each player. A pure strategy Nash equilibrium is an action profile with the property that no single player can obtain a higher payoff by deviating unilaterally from this profile. Finding Nash equilibria for various game. Suppose the game is a prisoner's dilemma game. And suppose the action profile is NC where the players will get a payoff of 2-2. Now suppose the player 1 fixes his action to NC and player 2 changes his action from NC to C. Then the player 1 will get a payoff of 0 and player 2 will get a payoff of 3. Therefore, player 2 has an incentive to deviate. Suppose you fix the action of player 2 to NC and change the player 1's action from NC to C. At that time, the player 1 will get a payoff of 3 and player 2 will get a payoff of 0. Therefore, player 1 has an incentive to deviate. So for NC, both the players have an incentive to deviate. So it is not a Nash equilibria. Suppose the action profile is NCC. Here player 1 gets a payoff of 0 and player 2 gets a payoff of 3. Now suppose the player 2 fixes his action to C and player 1 changes his action from NC to C. Then the players will get a payoff of 1, 1 where the player 1's payoff will rise from 0 to 1, which means the player